Hello everyone, this is grade 6, module 5, lesson 4 problem set. So for the first couple, we see calculate the area of each figure below. Figures are not drawn to scale. And I can see they got some triangles in here, and I even see a little bit down below in number 4 that I'll have a rectangle. And I know that that's area is length times width or base times height depending. And my triangle, I have my two formulas, 1/2 times base times height, or base times height over 2, or divided by 2. So we'll start in with, let's do A, or 1 here. Zoom over this way so you can see. I'm going to try to do the work off to the side and keep it as clean and neat as I can. I'll use base times height divided by 2, just because. And I need to find my base, and my base for the triangle is this whole thing. And I see it's broken into 2 pieces, the 15 right here and then the 6 afterwards. I'm going to put those two together to get 21 inches. Since I'm adding, it's not inches squared. If I were multiplying those two, it would be inches squared, but I'm just adding the 2 units. So 21 inches. That's my base, and my height is where the base meets with a perpendicular lines segment. So that's why there's a 90 degree right there, and that's going to be 8 inches. Well, then I'm going to divide that by 2. The 10 over here is this diagonal side, and the 17 is this longer diagonal side. So now 21 times 8, I'm going to show up above. I get 168, and that's inches squared now because I did inches times inches. And I'm going to divide it by 2. And I know that I can easily show that a division of 2. And I'm going to end up with 84 inches squared. So that's the area of this, the whole thing, because I added my 6 and my 15 together at the beginning to get my 21. So there's my first one of 84 inches squared. Let's take a quick look at the steps for number 4. And my first thing I want to do is I really want to take care of the easier stuff first. So I'm going to get rid of this rectangle. And I know it's length times width. And I like to write my formula first so I can identify what I'm doing. 19 times 12, and I'm talking about meters. And if I do 19 times 12, that's an 8. It's an awful 8. I'm going to end up with 228 meters squared. That's right here. And I always like to label on the inside to show my area as the inside part. And I see that I have 2 triangles that are going to be the exact same. My 5 right here and my 12. And then I have a 5 and a 12. So they're the same measurements. So I'll use one calculation to do it, and I'll do 1/2 base times height. Area equals 1/2. The base is 5 meters. The height is 12 meters. And again, I can do 1/2 times 5. I can do 1/2 times 12. I could do 5 times 12. Any order because of the commutative property. So I'm going to do my 2 measurements because I just tend to like to do those. And that's a nice fact in my head. 5 times 12 is 60. And that's meters squared now because I had meters times meters. And then I can take half of that. And half of 60 is 30. And it's still meters squared. So that goes in here. And because I found one of these, I can now put it in over here as well. So my last step is to figure out the area of this large one. And I'll do a different color for that. So I need the area of this large triangle. And I know this bottom part is the base. And I got a couple numbers here. I have a 5 there, a 5 there, and I see 19. And I know with my properties of rectangles, opposite sides are equal. So now I need to add these up. 5, 5, 19. I have 5 and 5 is 10, plus 19 is 29 meters. And again, it's just meters. And I'm going to cross out the ones that I don't need now. So 29 meters for this whole thing. It's not meters squared because I didn't multiply. I just added. So 29. Now I need the height because I know that area equals base height over 2 or 1/2 base times height. So my base is 29 meters. Now I need the height. And I see that I have perpendicular line segments right here from my base all the way to the top. And this 24 measurement I don't need because it's just showing this length out to my height. So I don't need that. I need this, the 7 meters. So 7 meters, and then that'll be over 2. So I'm going to do 29 times 7, and I'll keep my units there. I get 9 times 7 is 63, and then 7 times 2 is 14, plus 6 is 20. So 203 meters squared over 2. So now what I'm going to do is I'm going to take half of that. And half of 200 is 100. And I know that I'm going to have to do half of 3, which is 1.5. But I'll show this just so you can see why. And 2 goes into 0 0 times. And I bring down the 3. And it goes in once with 1 left over. So I can add a decimal point here. Bring that down. So now it's 101 and 5/10. Or you can do 101.5. So now I'll write that in. And then to get my area, I'll just add all of these up. 228, 30, 30, and 101 and 5/10. And what I should come up with, if I do my addition right, is the area of the whole shape should be 389 and 5/10 meters squared. And I did that in purple so you can see it because there's a lot of work being shown on this one. So let's zoom out and look. And luckily I can zoom in and out to show you work. And all my work's right there on the right-hand side. That's a lot of work for these questions, and they don't give you a whole lot of space. So just make sure you stay organized through it. What we're going to do now is take a look at page 2. So here's page 2, and I'll talk about 6. We'll peek at 7, and then we'll discuss the process for 8. But we're not going to do a whole lot of calculations because I don't want this video to get way out of control long. So let's take a look at 6. Darnell and Donovan are both trying to calculate the area of an obtuse triangle. Examine their calculations below. So they're trying to do area, and I see the formula they're using is 1/2 times base times height. And I can see that right here and right here. Now, the bottom statement says, which student calculated the area correctly? Explain why the other is incorrect. So let's really dive into this. By dive in, I mean let's get closer. So 1/2, and I see Darnell is saying the base is 3 and the height is 4. Donovan is saying 1/2, base is 12, height is 4. So it looks like they're consistent with the height. And we can see 4 inches right here. And that does look like the height because it's creating a perpendicular line segments there for a 90-degree angle. Now we need to figure out the base. And I know the base is of the triangle. So it's either going to be 5, 12, and then we have a 3 in there, but I see the solid line here is a measurement of a side. So that's the measurement of the base. The 3 inches is the measurement of the segment between the base and the altitude or the height. So we came down here to get the height where it meets the base, and they just gave you that measurement out to here. We don't need that measurement because it's not a measurement of the triangle. It's a measurement from the triangle to the height. So we need the 12. So I already know Donovan's good. If he calculated correctly, and I can see 12 times 4 is 48, and then half of that is 24. So it looks like Donovan's correct because Darnell used the measurement of the distance between the base and the height, and he did not use the base measurement. So that's what you'll do for your explanation for it, is just discuss what measurement Darnell used, and that Donovan used the correct base. Let's take a look at 8, and we'll see that we've got some mixed pieces here. The larger triangle below has a base of 10 and 1400 meters, and we got that labeled. The gray triangle has an area of 40 and 325 thousandths meters squared, and we got that labeled. So A says determine the area of the larger triangle if it has a height of 12 and 2/10 meters. So let me rewrite that so you can actually read it. And it's, this height is 12 and 2/10 meters. So to find that, and now you would have to plug in your base and your height and take half of it. And once you multiply these two and then take half, that's going to get the area of this whole shape. And then you'll have to figure out, write an equation to solve to determine the value of A, which is the area unshaded. So what they're really looking for is this white space here. So if you find the whole area, which is this whole one that you're going to calculate right here in purple, and then you can subtract out the shaded piece because they already gave it to you. That's going to get you A. Hope this helps. Thanks for watching, and good luck on your problem set.